Hi, in this lesson we'll be looking at something we're familiar but we'll link it with something else. Previously we went on the gradient between 2 points. You can find the gradient between the 2 points. We know that we'll say m will be equals to y2 minus y1 over x2 minus x1. In this case we can say if x was the x value here, and then I increase this by a certain value of h, which will therefore means I've got an x plus h value there because I've increased it by h. So the coordinates here will be x into f of x, because y is f of the x value, and then the coordinates there will be x plus h into f of x plus h. And therefore the gradient here becomes y2, which is f of x plus h, minus y1, which is f of x, divided by x2, which is x plus h, subtract x, which is now, because you can simplify the bottom, is x plus h minus f of x divided by h. Now that was the increase of h. So what happens if the increase of h is 0? So we've got a point here, I've got the x value. Now this becomes smaller, which means that this one comes closer and closer and closer to the a value. So which means that my gradient, which is this, will have that as it approaches 0. So we'll have a limit as h approaches 0. So we'll say here it is f dash of x, f prime, equals the limit as h approaches 0 of f of x plus h minus f of x all over h. This is same as that, but as this becomes 0, it means that this becomes a tangent. As this becomes 0, the point B comes close and this becomes a tangent. So therefore, if I wanted to find the gradient between 2 points, I use the normal equation I know. But if I want to find the gradient at a point, the gradient at this point, I will use this. So we come to a section which we call differentiation from first principle, where we use that formula. It's f prime is equal to limit as h approaches 0 of f of x plus h minus f of x all over h. How do we do this? Let's look at the example. We will say, can we differentiate f of x equals x squared minus 5x from the first principles? So once they talk about the first principles, the important thing is to remember the rule. The law is f dash of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so therefore as I differentiate from first principle, so f dash of x is equals to the limit as h approaches 0 of f of x plus h minus f of x all over h, which will give us the limit as h approaches 0. Now what is f of x plus h? Instead of x, they put x plus h. Instead of x, I put x plus h. So it will be an x plus h, which is squared, minus 5 times x plus h, because instead of x, I put x plus h. Now I must subtract the f of x. F of x is the whole thing. I must subtract the x squared minus 5x. So all of this is divided by h. Now I can simplify. So it's the limit as h approaches 0. Simplify this is x squared plus 2xh plus h squared this is minus 5x, this and this is minus 5h, this and this is minus x squared, this and this is plus 5x all over h, which is the limit as h approaches 0. If I simplify, the x squared minus x squared will cancel off. The 5x and the minus 5x will cancel off. So I'm left now with 2xh plus h squared minus 5h all over h. I want the limit as h approaches 0. I can't plug in 0 here because it's dividing by 0. There's h on top as well. So it's the limit as h approaches 0. I can factorize h as a common factor. So I have 2x plus h minus 5 all over h. Now you can see the h cancels h. So now it cancels. So I'm now left with the limit as h approaches 0 of 2x plus h minus 5. So now I can substitute the value of h as 0. And the answer, if I plug in h there, the answer is 2x minus 5 because I've plugged in 0 for h. Let's look at another example. Say differentiate this from first principle, because they say first principle, so we start to say the f dash of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, must know by head this formula, over h, so which is equal to the limit as h approaches 0. Now what is f of x plus h? In f of x, where there is x, I put x plus h, so there I'll put x plus h, so this is square root of x plus h. Then subtract. What is f of x? F of x is this, so I subtract the square root of x, so all over h. Now what must I do? We can see that this together, I can't put h here, because if I put h as 0, I'll have a 0 here, and this will be 0, and then it will be square root of x, which is minus square root of x, is 0 over 0. So I must do something. So it's the limit as h approaches 0 of x plus h minus square root of x all over h. Then I must multiply this with a special one. So special one, the conjugate of this. So it will be square root of x plus h, now plus square root of x divided by, there is x plus h plus square root of x. Now I can see what's going to happen. So it's the limit is h approaches 0. Now these and this, the numerators are the factors of difference of two squares, so it becomes the square root of x plus h, which is squared, minus square root of x, which was squared. So all over this one, I leave it as it is, so it's times the square root of x plus h plus square root of x. So if I simplify the top, what do we get? The limit as h approaches 0 of the x plus h, because that is squared, it get rid of that, squared, get rid of that is minus x, over is h into square root of x plus h plus square root of x at the bottom. So the x and the x cancels off, so I'm left with the limit as h approaches 0 of h over the square over h, then the square root of x plus h plus square root of x. So you can see that the h cancels the h, so I'm left now with the limit as h approaches 0 of 1 over square root of x plus h plus square root of x. So what is my answer? Now I can put h as 0 if I plug in 0 there, so the answer would be 1 over square root of x plus the square root of x, because I plugged in h as 0. Now the answer is 1 over what is square root of x plus the square root of x, that's 2 square root of x. That was the first part. Look at the second part of it. It says Hence, find the gradient of the tangent to the curve f of x equals x at x equals 9. So we did find the gradient, and the gradient was 1 over 2 square root of x. So we know that f dash of x equals, in the previous example, equals 1 over 2 square root of x. So now they say, what will be the gradient then when x is 2, is 9? So when x is 9, therefore I'll have my gradient. The gradient will be equal to f dash of 9, because that's when x is 9, which is 1 over 2 square root of 9. So my answer would be 1 over 2, and the square root of 9 is 3, so the answer is 6. So that is the gradient when x is 9. So you can try and do these few problems from your AP Maths book, grade 11, page 85, exercise 5.2, numbers 1 to 4.